Do you fear going the way of the dinosaurs? Do movies featuring asteroids hurtling towards Earth at tremendous speeds make you nervous about seemingly impending doom? Well, this video should put those fears to rest, as it will discuss asteroids and our ability to defend against them. But first things first, what are asteroids? Asteroids are planetesimals that were left over from the birth of our solar system. Asteroids are rocky because they formed in the inner solar system, where only metal and rock condensed. When this process took place in the outer solar system beyond the frost line, which is the distance from the sun where ice is able to form, comets were formed. Imagine the two objects being formed in two places on a mountain. Asteroids formed from the main body of the mountain, while comets formed on the peak of the mountain, each gaining the material makeup of their respective location. Most asteroids orbit far away from the inner solar system and tend to be in one of two major bodies, the Oort cloud and the Kuiper belt. The Oort cloud consists of about 1 trillion asteroids that have random orbits. The Kuiper belt contains about 100,000 asteroids that orbit in the same plane as the planets. Along with these two main bodies, there is also a belt of asteroids that exists between Mars and Jupiter, called the main belt. Jupiter's gravity is the primary reason this body exists. Asteroids' orbits are created and impacted by the gravity of the planets and other massive bodies. However, there are tiny regions of space where, if entered by an asteroid, could cause an impact into a planet. These regions are called keyholes. The most recent case of any danger being caused by a keyhole was in 2005 with the asteroid Apophis. While it missed Earth, there was a possibility of it hitting the Earth in the future if it had gone through the proper keyhole. However, the probability of this happening is so insignificant, it's not worth the concern. But what would happen if Apophis did go through a keyhole? Well, what could we do? Rest assured, we have solutions. Although there are copious amounts of different defense methods, we're only going to be talking about 3 today. The first method has to do with the use of solar sails. Solar sails are a form of spacecraft propulsion system that uses very large mirrors to harness and control solar winds. In the case of an incoming asteroid, we could focus solar winds at the asteroid using solar sails to slightly blow it off course. The winds would also blow the dust off of the surface of the asteroid, thereby shrinking it and affecting its orbital path. The second method is fairly simple and much more feasible. We would send a giant impactor spacecraft on a collision course with the asteroid. The collision itself would slow down the velocity of the asteroid, which would, in theory, give the Earth enough time to move out of the way. We've hit asteroids before, most famously with the Deep Impact mission, so this option is legitimately practical. The only potential problem would be the giant impactor pushes the asteroid into a keyhole, which would then only postpone the asteroid's impact with Earth. That's where method 3 comes into play. The third method is somewhat like the second method, but with an additional measure. This push-or-tug spacecraft would have 2 pieces, a weight to ram into the asteroid and a probe to orbit it. The asteroid's gravity would attract the probe, but at the same time, the probe's gravity would attract the asteroid. The probe would then very slowly move the asteroid using the force of gravity into a safe orbit. Scientists are continuously monitoring Earth-crossing asteroids whose paths intersect Earth's orbit, and near-Earth asteroids that approach Earth's orbital distance to within about 45 million kilometers and may pose an impact danger. Now, with all of these defense mechanisms, instead of this, we can have this.